This video is the implementation of sentimental analysis. First, we are importing all the necessary packages like NumPy, Pandas, scikit-learn, and Keras, and all the sub modules which are required for the implementation. And then we have imported the data set, which is split into test and train. We have imported two data sets separately. We are reading both of them. We've named the training dataset as DF and test as DF validation. We are encoding them because there are some sparse places which are to be skipped. For that, we have to encode the dataset to ensure while decoding no error should be occurring. And then we are printing the dimensions of the dataset, that is the shape of that. And then we are printing the first 5 records of the dataset. Head represents the first 5 records. Now we are counting the isResponse field, which has got 2 data, happy and not happy. The happy data has around 2,65,000 data, and the not happy has got around 1,24,000. Now we are mapping happy and not happy as zeros and ones. We know that machine learning cannot understand categorical data, so we are converting them to an integer data type. After that, we are converting all the text into lowercase data, and we are substituting any special characters and numbers as empty space. And now we are describing it to check if everything is converted properly. We are importing the regular expression tokenizer module from the NLTK, which is used to tokenize the text we have got. Tokenizing is nothing but splitting the sentence into a list of words. We are performing tokenization for both the test and train datasets. And then we are removing the stop words from the data we have got. Stop words are nothing but the articles that we use while forming a sentence, which are to be ignored in machine learning. And also we are removing the stop words both in test and train datasets. We are checking if the removal is performed properly. Now, as we have got a list of words without any articles, that is after performing tokenization and removing stop words, we have got a list of words. Now, the list of words, we are removing the commas and replacing it with a space. Max features is nothing but the number of words we are going to select from the tokens. We are converting the text to sequence of integers, that is machine learning can understand only numbers. It cannot understand the text which we read. So we are converting it to a sequence of integers by using the tokenizer.text to sequences function. Now we are ready to build the model, a sequential model. Before that, we are performing embedding. We use embedding for handling sparse data, which is often used for text processing. It transforms high-dimensional categorical data into a dense vector of fixed size, which is easier for the model to interpret. We are using dropout for regularization of the data, and also we are using optimizer as ADAM and activation as softmax. We have took accuracy as a metric for the implementation. With all these processes, we can get a summary of the model which we are going to build. We are now splitting the data into test and train, after which we are trying to fit the model. We have used the dropout function to avoid overfitting of the model. Here we have used 7 epochs, and the batch size was set to be 128. After all the epochs, we can know that the accuracy is about 89%. Gradually it has increased from 81 to 89. If the max features, now we have set the max features as 2000. If it had been set as 3000 or even more, we would have got a much more better accuracy. Now we got the accuracy as 86%, which is a very good model. Now we are checking the description of the test dataset, and then we are also checking the tokens of the test dataset. And also we are using the tokenizer.text to sequences function here to convert the the text into integer data type. The patch sequences are used to check whether all the words are of same length. Now we are printing them. Now we have got the text into an integer form, and which is of almost same length. Finally, we are creating a sentiment function from the above model which we have created. By giving a sample review, we can predict whether the review which we have given is positive or negative. With this analysis, we get to know the user in a more precise way, which helps us to develop the application according to their preferences.